We have this C here, which is the center of curvature of the mirror. If I completed the circle, that would be the center. So the distance from the center to the mirror surface is the radius. Halfway between that point is the focal length with our F here, and that is also the focal point where all rays of light that come parallel to the optical axis will reflect through the focal point. We have our objects here, and the height of the object is 1 centimeter, so HO is 1 centimeter. The distance of the object from the face of the mirror is 4 centimeters. The center of curvature was 5 centimeters, and therefore the focal distance is 2.5 centimeters. There's 4 light rays that we know exactly what happens to them when they hit the mirror. The first one is whenever a light beam comes off of the top of the object and goes parallel to the optical axis and hits the surface of the mirror, we know that it will reflect through the focal point. And so I take it straight through the focal point, and we know it goes off that way. The virtual light beam will go behind the mirror, and it goes at the same angle that the reflection went off at. The next ray is going to go through the focal point straight onto the mirror, and we know that it reflects parallel to the optical axis, and so it reflects like this, parallel off. The third ray that we know about goes in line with the center of curvature. It goes off the object, hits the mirror, and it will be reflected exactly back and through the center of curvature and off at this point. And the very last beam that we know how it works is the beam that goes straight to the center, and at this point the law of reflections holds, and the angle that it comes in at will be exactly the same angle that it reflects off at. So you could actually measure that to find that point. The reflected beam from this one will go straight back with the reflection, and as does all the other ones. The reflected beam goes back into the mirror as a virtual beam inside the mirror, and we use that as a dashed line to show the virtual beams, and they follow the reflection pattern. I'm going to just straighten this one up just a little bit because these actually will not converge for this image in the back here. So let's get that one a little bit. Okay, now what we are going to look for is, you want to look for where all the beams, whether they be virtual or real, would converge. So right in this little spot here, all of those light beams converge, and that's where your image is going to form. So we draw the image right there, and it goes up to the, from that point up to the optical axis, and the tip of the object is where the light beams will converge. So right in there. I'm going to actually outline this one in purple so that we can tell that this is the image right there. Next, we're going to compare that image to the object, and we compare the size. And if I measure the image size, it's about 2 centimeters, so it is magnified, so it's larger. The next thing I'm going to do is compare the orientation. This one's upwards and this one's pointing downwards, and so we call that inverted. And the next thing we want to do is decide if it's real or if it's virtual. So what we're seeing is anything that's made of real light beams, where the actual light beams are the ones that are converging, is real. If it was the virtual beams that were converging, it would be a virtual image. So this is a real image. So real, inverted, and magnify. A real image can be projected on a projector and a virtual image cannot.